So we continue with our Jamb solutions to the different Jamb past questions that we've started for some time now. And today we are going to be looking at the 2018 chemistry Jamb question. 2018 chemistry Jamb question is what we are going to be focusing on today. So let's look at it now. The first question says that a given amount of gas occupies 10.0 dm cube at 4 atmosphere and 273 degrees Celsius. It says the number of moles of the gas present is now a molar volume at STP was given to be 22.4 dm cube, and then the options were also we have the options there. So let's work it out and see what we can come up with as regard the number of moles of the gas. So it's still the ideal gas equation that we are still contending with, and our answer should be about 1.90 mole. Basically, we convert to STP condition using molar volume at a given condition, which is 22.4, and then what's it called? 4 at 4 atmosphere equals to 5.6, and that will be like 10 divided by 5.6. That's about 1.79. Then approximately about 1.90. And then this one says, according to Charles' law, the volume of a gas becomes zero at minus 273. This should be the answer to this one. That's C. So all molecular motion stuff, this is absolute zero, and it's like 0 Kelvin, so to speak. This one says a substance that is used as a ripening agent for fruits is it ethane, propane, methane, or butane? The answer is ethane, and the reason is because ethane is a plant hormone used industrially to ripen fruits. The sulfide, which is insoluble in dilute hydrochloric acid, is FeX. That's iron sulfide, copper sulfide, zinc sulfide, or sodium sulfide. The answer is copper sulfide. That is the soil that is insoluble in dilute HCl. And copper 2 sulfide is one of the few metal sulfide insoluble in dilute acid. Okay. What is the pH of 0.001 mole per dm³ solution of sodium hydroxide? The answer is 11. And the reason is just this. Don't forget that POH is the negative logarithm of OH. So if that is the case, that means with pH equals to minus log 0.001, which equals to be 3. Now, that's POH. The pH is now 14 minus 3. How did we arrive at that? Because pH plus POH equals to 14. So 14 minus 3 will give us the pH of 0.01 mole per dm³ solution of sodium hydroxide. So 11 is the pH. Okay, so we look at it like that, and that is how we arrived at 11. Okay. Now, the type of bonding in this particular compound is what? Is it coordinate? Is it electrovalent? Is it metallic? Or covalent? And the answer is coordinate. Ligands, ammonia donates lone pairs to copper 2 ion by coordinate covalent bond. So it's a coordinate bond that exists, or coordinate covalent bond that exists between those atoms here that forms the complex. Okay. All right. So which of the following is an example of a chemical change? Is it dissolution of salts in water, rusting of iron, melting of iron, separating a mixture by distillation? The answer is rusting of iron is an example of chemical change. And we said rusting forms a new substance, iron oxide, which is a chemical reaction and it's a chemical change. Okay. To what temperature must a gas at 273 Kelvin be heated to double both its volume and pressure? Is it 298 Kelvin, 546 Kelvin, 819 Kelvin, or 1092 Kelvin? The answer is 1092 Kelvin. And basically what you are saying is that for us to be able to the temperature that we'll get for us to for a gas that's at 273 Kelvin to be heated to double both its volume and pressure will be what? T2, which will be equals to 2V multiplied by 2P to double both its volume and pressure. So that will be equals to 4 times T1, which equals to 4 times 273, which is 1092 Kelvin. Okay. According to the kinetic theory, an increase in temperature causes the kinetic energy of particles to A, decrease, B, increase, C, be zero, and then D, remain constant. So the answer to this one is increase. And the reason is because temperature is directly proportional to average kinetic energy. Okay. An element used in the production of matches is nitrogen, aluminum, copper, sulfur. The answer to this one is actually sulfur, D. And sulfur helps ignition by lowering the activation energy in match heads. Okay. Which of the following gases may not be dried with concentrated sulfuric acid? Is it HCl, is it NH3Cl2, or SO2? The answer to this one is actually NH3. And NH3 reacts with H2SO4 to form ammonium sulfate, so it is unsuitable for drying with it. Okay. This one says that the consecutive members of an alkane homologous series differ by CH, CH to CH3 or CNHN. And we know that they differ by CH2, that's for homologous series. Each successive alkane increases by one CH2 group, okay? A correct electrochemical series can be obtained from sodium, calcium, aluminum, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, by interchanging aluminum and magnesium, zinc and iron, zinc and lead, or lead and hydrogen. Now, the proper thing to do is to interchange lead and hydrogen. So when you do that, because lead is less reactive than hydrogen and should come after hydrogen in the series. So that's the reason why we have to interchange it. Okay. The basic postulate of the kinetic theory of gas is that gas molecule moves in straight lines between collision. This implies that collisions are perfectly elastic. Forces of repulsion exist. Repulsion and attraction are balanced, and collision are inelastic. Okay. So the answer to this one is collision are perfectly elastic. Okay. Elastic collision means total kinetic energy is conserved. Okay. So we move on and say on which of the following is the solubility of a gas dependent? Is it nature of solvent, nature of solute, temperature, pressure? Is it A, 1, 2, 3, and 4, or option B, or option C, or option D? So let me know what you feel the answer is in the comment section. Okay. So the right answer here is option A, 1, 2, 3, and 4. Okay. And all 4 factors affect gas solubility in liquid. So everything is correct in that regard. Nature of solvent affects the solubility, affects gas solubility in liquids. Nature of solute, temperature, pressure are also factors that affect it too. Okay, so which of the following statements is correct about the periodic table? Is it option A, option B, option C, or option D? So which of the following statements is correct about the periodic table? Okay, so the right option is option B. The valence electron increase across the period. The valence electron increase across the period. So as you move left to right, 1 proton and 1 electrons are added. Okay, so that's the right one there. The periodic classification is an arrangement of the elements. Is it by the atomic weight, isotopic weight, molecular weight, or atomic numbers? The answer here is D, atomic numbers. So the modern periodic table is based on increasing atomic number. That is the proton count. Okay. The next one says that if 1 liter of 2.2 molar H2SO4 is mixed with 10 liters of water, the final concentration is it 2.2 molar, 1.1 molar, 0.2 molar, 0.11 molar? The answer is 0.2 molar. Why is that? Don't forget that what we are using basically is just the C1V1, C2V2. So the concentration that we're looking for, which is the final concentration, will be equals to 2.2, which is the molarity of the acid multiplied by the volume of the acid, divided by the what's it called? The the volume of the of the of water that was used in that particular scenario. So when you do that, you end up having 0.2 molar. Okay. In the experiments, the litmus paper will initially be bleached. It will turn green, it will turn red, it will turn blue. It will turn blue, and this is a likely setup involved an ammonia gas test, and that turns red litmus paper to become blue. Okay. The boiling of fat and aqueous caustic soda is referred to as hydrolysis, esterification, acidification, or saponification. The correct answer here is saponification. And saponification is the alkaline hydrolysis of fat to form soap. Okay. Then, which of the following pairs of substances will react further with oxygen to form a higher oxide? Is it option A, option B, option C, or option D? So the right answer to this one is actually option D, SO2 and NO. They react further with oxygen to form a higher oxide. So both SO2 and NO are lower oxide that can be oxidized to SO3 and NO2 respectively. Okay. In the preparation of oxygen by eating KClO3 in the presence of manganese 4 oxide, only moderate heat is needed because the catalyst can act by lowering the pressure of the reaction, increasing the surface area of the reaction, increasing the rate of the reaction, increasing the energy barrier of the reaction. Okay. The right answer here is increasing the rate of the reaction, and MnO2 acts as a catalyst by lowering activation energy and increasing the reaction rate. Okay. So methanoic acid mixes with water in all proportion and has about the same boiling point as water. Which method would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? Is it extractive distillation, filtration followed by distillation, neutralization with sodium hydroxide followed by distillation, or neutralization with sodium hydroxide followed by filtration? The answer is filtration followed by distillation. When you filter, you can get the sand. You get the sand on top of the filter. It takes it out. And then when you look at water and methanoic acid, because of their boiling points, you can actually use varying boiling points. You can actually use distillation to remove them at their various boiling points. Okay. So just like what I explained earlier. All right, now let's move on and let's talk about question number 24. A quantity of electricity liberates 3.6 grams of silver from its salts. What mass of aluminium will be liberated by the same quantity of electricity? So these are the options that we have been provided with, and I want us to, excuse me, please. I want us to practice and to engage and see what we can come up with as an answer. The answer to this one is about 0.3 grams, and the mass of silver deposited is 3.6 gram. If that is the case, molar mass of silver is 108 gram per mole, and then the number of moles of silver electron deposited is just 1, and the molar mass is 27. And then for aluminium, the molar mass is 27. And the number of electrons deposited by 1 mole of aluminum is actually 3 electrons. Now, having said that and arrived at that, we can now say that to calculate the number of moles of silver deposited, it will be moles of silver deposited, which will be equals to the mass of the silver, deposited divided by the molar mass. So that will give us 0.0333 moles. Now, since 1 mole of silver requires 1 mole of electron, mole of electron used is also what? 0.033 moles. Okay. All right. So if that is the case, the second step is to use the same number of moles of electron to calculate mass of aluminium. Don't forget that we need 3 electrons or 3 moles of electrons that are required for 1 mole of aluminum that will be deposited. So mole of aluminum will be equal to 0.0333 divided by 3, which will be equal to 0.01111 mole. So mass of aluminum will be what? 0.0111 multiplied by 27. That will give us 0.3 grams. So that's how we come that we provided just now. Okay. So this one says that it says that the suitable reagent for the laboratory preparation of nitrogen are, is it option A, option B, option C, option D? So the answer to this one is option A, sodium diazonitrate 3 and ammonium chloride. So what's it called? Option A. And the reason for choosing option A, is what we have here. So this decomposes to release nitrogen gas when heated. So when sodium diazonitrate 3, and ammonia come together, they will release they will release nitrogen gas, when they are heated. So that's why it's a suitable way to prepare nitrogen in the laboratory. This one says that the number of electrons in the valence shell of an element with atomic number 14 is 1, 2, 3, or 4. It's actually 4. The atomic number 14 is silicon. Electron configuration is 284. That 4 outside shows that the valence shell of that element, the number of electrons in the valence shell is 4. Okay. What volume of oxygen will remain after reacting 8 cm cube of hydrogen gas with 20 cm cube of oxygen gas? Is it 10 cm cube, 12 cm cube, 14 cm cube, or 16 cm cube? The answer is 16 cm cube, and the explanation is what is given below. Now, to solve this question, we apply the stoichiometry of the reaction between hydrogen and oxygen using the principle of volumetric and relationship of gas. That's the Gay-Lussac law. Now we write out the balance equation. It implies that 2 volumes of hydrogen will react with what? 1 volume of oxygen. Okay. So based on that, the first step that we need to carry out is to determine the limiting reagents. And then we are given that hydrogen is 8 cm cube, oxygen is 20 cm cube. According to the equation, 2 cm cube of hydrogen will react with 1 cm cube of oxygen. So it means that 8 cm cube of hydrogen will require 1/2 times 4, which will be equal to what? 4 cm cube of oxygen. So 8 cm cube of hydrogen will need what? We need 4 cm cube of oxygen to react with. So if that is the case, we'll now look at what is being supplied. Oxygen supply is 20 cm cube. Therefore, used oxygen is 4 cm cube because that was what was used up. Therefore, the remaining oxygen will be 20 minus 14, which will be equal to what? 16 cm cube. And that's what the remaining oxygen is. Okay, so moving along now to the next question that says that if one of the following oxide is heated, okay, if one of the following oxides is heated with hydrogen or carbon using a Bunsen burner, it is not reduced to the metal. Which one is it? Is it lead oxide, magnesium oxide, copper oxide, or tin oxide? The answer to this one is actually magnesium oxide. Now, magnesium is very reactive and cannot be reduced by hydrogen or carbon, okay? It says the IUPAC name for the compound, for this compound is what? The answer is actually 2-methylbutane, You look at the longest chain, carbon, which is 4 carbon. Then you look at the substituent that was attached at position 2. And that's how we came about naming that. Aqueous salts, aqueous salts M gives a white precipitate with sodium hydroxide and aqueous ammonia, both soluble in SS. The cation is in M is what? Is it zinc, Is it calcium? Is it aluminum or lead? So let's look at it. It's zinc is the answer. And zinc hydroxide dissolve in excess sodium hydroxide and ammonia. Okay, so zinc is the answer. So the next one says that what is the concentration of a solution containing 2 grams of sodium hydroxide in 100 cm cube of solution? What is the concentration of a solution containing 2 grams of sodium hydroxide in 100 cm cube of solution? Given the parameters that sodium at relative atomic mass is 23, oxygen is 16, and nitrogen is 1. So when you do the calculation right, you should end up having 0.50 mole per dm cube, which is option B. And how did we arrive at that? Now, molar mass of sodium hydroxide equals to 40 grams per mole. 2 over 40 equals to 0.05 mole in 0.1 dm cube. So when you divide 0.05 in that one 0.1 dm cube, you end up having 0.5 mole per dm cube. How many atoms are in 6 grams of ethane? Oh, sorry. Pardon me, please. Let me take that question again. How many atoms are in 6 grams of magnesium? Okay. So we look at the option, and the answer to this one is 1.51 times 10 to the power minus 23. Now, let's go about the explanation. When we want to, first and foremost, we look at the number of moles by dividing, by doing a division between the mass and the molar mass. The mass that was given is 6 grams. The molar mass in this particular one is 24. So that means you are doing is 0.25 moles. That's what you're working with. So you now multiply by the constant that was given to us 6.02 times 10 to the power 23. And that will give us 1.505 times 10 raised to the power 23. So 1.51 times 10 raised to the power 23 is the correct answer. Okay, the radioisotope used in industrial radiography for checking wells and castings is it carbon-14, phosphorus, cobalt 60, or iodine 131? The answer to this one is cobalt 60. And cobalt 60 emits gamma rays used for non-destructive testing. Okay. Beryllium and aluminium have similar properties because they are both metals. B, because they belong to the same group. C, because they belong to the same period. And D, because they are positioned diagonally to each other. The answer is just the diagonal effect or the diagonal relationship. So the correct answer to this one is D, position diagonally to each other. So diagonal relationship causes chemical similarities. So when you have atoms that are diagonally positioned in the on the periodic table, most of the time they have similarities in their properties, and that is one thing we must take note of. So that similarity exists between beryllium and aluminium because they have on the go diagonal relationship. Okay. All right now. So this is the question. And in the equation shown, the equilibrium constant is given by, is it A, is it B, is it C, or D? The right answer to this one is actually C. And how did we arrive at that? Equilibrium constant equals to product concentrations over reactants, each raised to their stoichiometric coefficients. So you look at the product concentration, the products are G and H, and then their coefficients are P and Q. So you do a product concentrations over the reactant concentration, each raised to their stoichiometric coefficient. And by so doing, we get the equilibrium constant. Okay. The reaction, and that's the reaction there, demonstrates what? Is it the basic properties of ammonia, the acidic properties of ammonia, the reducing properties of ammonia, or the oxidizing properties of ammonia? The answer is the reducing properties of ammonia. This shows the reducing properties because if you look at the equation closely, you discover that what ammonia is doing basically is carrying out a reduction reaction, so to speak. For every substance that it is reacting with there, it is actually reducing that substance on the product side. And that is what you can see there. So NH3 donate electron, reducing other substance or substances in the process. The next one says that the salts that react with dilute HCl to produce a pungent gas that decolorize acidified KMNO4 is Is it Na2SO4, Na2SO3, Na2S, or Na2CO3? And the answer is Na2SO3. And the reason is because when you react Na2SO3 with hydrochloric acid, SO2, which is a pungent gas, reduces KMNO4. So that's that for that. Okay, the refreshing and characteristic taste of soft drink is due to, is it carbon 4 oxide, carbon 2 oxide, soda, or glucose? The answer is carbon 4 oxide. And the reason is because CO2, when it dissolves under pressure, it forms carbonic acid, which gives a kind of fizz or a fizzy feel, so to speak. And that is the chemistry behind, these characteristic tastes that we see in most of our soft drinks and all these soft drinks that we have, on display or that we in the market. So it's carbon 4 oxide. That is the right answer. Okay, which of the following are mixtures? Petroleum, rubber lattice, vulcanizer solution, carbon sulfide. So you tell me which of this option. Is it option A, option B, option C, or option D? In that order. Now the answer is A, which is 1, 2, and 3. So these ones are the mixtures. That's petroleum, rubber lattice is a mixture, and vulcanizer solution is also what? A mixture. So the answer there is that all three are mixtures of various components. Carbon sulfide, on the other hand, is a pure compound. So that makes it a bit different from the three other options that we have there. Okay. All right. See? A balanced chemical equation obeys the law of what now? Is it conservation of mass, definite proportion, multiple proportion, conservation of energy? The answer here is A, law of conservation of mass. Why is that? Because it is said in that law that atoms are neither created nor destroyed in chemical reactions, okay? So when air is passed through alkaline pyrogallo and then over quicklime, the only gases left are, is it nitrogen and carbon dioxide? The rare gases, nitrogen and oxygen, nitrogen and the rare gases. Now the answer is nitrogen and the rare gases. And basically, alkaline pyrogallo absorbs oxygen. Quicklime will absorb water vapor and CO2 left over. So nitrogen and noble gases is what will now be left, after this alkaline pyrogallo and quicklime had been acted upon air. So let's take note of that. Very, very important. So we now look at the next one. It said in the lab, preparation of oxygen, the gas cannot be collected by downward displacement of air because A, the density of oxygen is greater than that of air. The density of air is nearly the same as that of oxygen. Oxygen is a component of air, and air is an impure substance. The answer here is that the density of oxygen is greater than that of air. So, and that's why it can be collected by downward displacement of air because the density of oxygen is greater than that of air. Okay, so oxygen is denser than air and will displace air upward, not suitable for downward collection. Okay. KClO3, to give us KCl plus oxygen. The importance of the catalyst in this reaction is that A, heating may not be required before the reaction takes place. B, the reaction is controllable even at high temperature. C, the reaction produces large quantity of oxygen. And then D, the reaction takes place more rapidly at lower temperature. So the answer to this one is actually option D. The reaction takes place more rapidly at lower temperature. And basically is manganese dioxide lowers activation energy, making decomposition faster at moderate heat. Okay. So which of the following is used to power steam engines? Is it lubricating oil, coal, bitumen, or diesel? The answer is coal. Now, coal was historically and industrially used to generate steam in engines. Okay. Sorry, let's just okay. So question 45 says that what volume of 0.5 molar sodium hydroxide is required to neutralize 10 cm cube of 1,2 5 molar H2SO4? Is it 5 cm cube, 10 cm cube, 20 cm cube, or 50 cm cube? The answer is 50 cm cube. To solve this titration problem, we will use the acid-base neutralization concept and apply the formula M1 V1 over N1 equals to M2 V2 over N2. Okay. So if you look at it, that the acid is diprotic, so that means N1 for the acid will be 2. So M1 is 1.25 mole per dm cube. V1 is 10 cm cube. Now the base sodium hydroxide is monoprotic, so the base, the N2, the number of moles of the base will be 1. So M2 equals to 0.5 mole per dm cube. So V2 now, we can calculate our V2, just look for it and then make V2 the solution of the formula. If you do it well, you'll be getting 50 centimeters cube. Okay, so to what volume must 300 cm cube of 0.60 molar sodium hydroxide be diluted to get 0.40 molar solution? So these are the options. So to what volume must 300 cm cube? So if you calculate it right, you have 450 cm cube. And what we are using basically is the C1, the dilution formula. C1 V1 equals to C2 V2. And when you plug it in right, you get your V2, which will be equals to what? 450 cm cube. Okay. Diamond is a bad conductor of electricity because its bonding electrons are used in crystal lattice formation, covalent bond formation, metallic bond formation, coordinates bond formation. So the answer to this one is actually covalent bond formation. Diamond is a bad conductor of electricity because it's it's the bonding that exists between the electron is covalent bond formation. So all 4 valence electrons in carbon atom forms a covalent bond, no free electrons to conduct electricity. So that's that for that. This one says that, a minute, please. This one says that the reaction between an organic acid and alcohol in the presence of acid catalyst is known as saponification, B, dehydration, C, esterification, D, hydrolysis. So the answer to this one is actually what? Esterification. Yeah, an ester is formed. An explanation, organic acid plus alcohol will give ester plus water in the presence of H2SO4. So that's how that's what we see play out, when that happens. So esterification it is. And the constituents common to duralumin and alnico, is it cobalt, is it manganese, aluminum, or magnesium? The answer is aluminum. And basically, aluminum is present in both duralumin, which contains like I was saying, aluminum is present in both duralumin. That's Al plus copper plus magnesium plus manganese, and alnico, which is aluminum plus nickel plus cobalt. Okay. The solubility of a solid that dissolves in a solvent with the libration of heat will increase with increase in temperature, decrease with decrease in temperature, and decrease with decrease in temperature, and not affected by the changes in temperature. So the answer is a decrease with increase in temperature. So there's a inverse proportionality in this regard. So for exothermic, the dissolution, increasing temperature shifts equilibrium, so equilibrium left. That is the solubility, therefore, decreases. So that's that for that. All right, thank you for joining in, and I'll see you in the next video. Bye-bye for now.